Okay, this is assignment number 4. The first question asked us to create a color selected 3D optimized class to use that to pass a single matrix instead of the 3 into the objects world that is a product of world view and projection. So here you can see I did that, so I've got in this struct here I've got world view and projection, and that takes those in. Over here in the CPP, or the DirectX app, what I do is I take that and I calculate the world times the view and the projection, and I send it over. And then when I play it, we get the same box that we got before. Alright, so then question 2 said to use that same shader but create a scene with 5 objects at different positions, but minimize the number of matrix multiplications. So what I did for that one is I did alter the shader just a little bit, so now it's one struct, so it takes the MVP and the color both. And then here I have the multiplication done. I also, since there's multiple models, I made a matrix for the translation. And so we're using the same model a few times. Go ahead here and there's 5 models on the screen. I guess this could be minimized further by just having these two multiplied together up top, and then just doing transworld times the VP for each of these, so these don't have to keep getting recalculated, which is probably what I should have done to begin with. And I'll fix that. Alright, so then the third question said to make a pre-made model of the unit pyramid and change the UV coordinates so that the texture faces are like this. So here I've got my create pyramid wrap textures, and I've gone through and I've set the vertices so that way it can be grabbing from the right part of the texture. So when I press play, you see here that we've got these textures on each side. It's kind of a big triangle. Alright, so then the fourth question said to do a new box and have it wrap like this. So, you know what I did is I kind of used this as a guide to find the UV coordinates for each of the corners. And then I took the box and put those coordinates in there. And in the end, we have a box that has this texture on it. Alright, so we got B, R, F, L, bottom, and top. Alright, and then the last one says to create a shader texture class to encapsulate the work needed to set up the texture HLSL. So that's going to be over here. So you can see the init demo doesn't have much in it anymore because that's all been moved into the shader texture class. And so then down here, when it calls it, gives it the projection, gives it the world, and when we press play, then we're still going to have that cube that we started with. Alright, so then the first further work said to look at demo number 16, set the model to unit box, and run it on the 3 different textures to see what's going on. So, for example, on this one, when we run it, you see that the texture is all one color, it's just white. We can do the same thing for any of these. Alright, and so what seems to be happening is when these are created, they're just default assigned a U and a V that equals 0. So what's happening is it's taking that texture and just getting the very corner of it and then applying that color to the entire model. Alright, and then the second further work question said to do a performance test with a lot of cubes. So starting here, I've got the shader color, HLSL, and it's going to create a bunch of cubes. And so we've got this big box of cubes here. I've got a pretty fast computer, so this is running at 320 frames per second or so. But then if we get rid of that and we go back to that optimized shader that we created earlier, pre-compute that position only once, do the set to context only once, and then when we've got the same box, we're seeing that we're getting 620 plus frames per second. So it's nearly double the amount of frames per second just by making those couple changes. Alright, and I believe that is everything. Thank you.